Okay, so today we've got a logarithm problem. Okay. Given that log 2 is equal to 0.631 dot dot dot, find the smallest positive integer a such that 3a is greater than 2 to the power of 102. This is from the Mandelbrot number 3, which by the way is named after the Mandelbrot set, but that's for a different time. Okay, so we've got a couple of key words in this problem. We've got smallest, we've got positive, and we've got, of course, greater than or equal to. No, greater than. No, not equal to. So, if we think about it a little, we can see that the smallest positive integer a is going to be when 3a. Oh, it's a bad color. It's a really bad color. Let me erase that. So it's gonna be when 3. Give me a sec. 3a is equal to 102 to the power 102, because you want the smallest positive integer, right? Which, if it's any greater, if it's greater than what it looks like here, then you want. I'm losing my mind now. Then you have, if it's greater than this, if it's greater than the a that's here, then you have not the smallest, right? So here we go. I mean, if it's an integer as well. I missed that word. It's an integer as well. So if it's not equal, well, if it's not an integer that's of a that's equal, then we'll have to round up. Let's start the problem. Okay, so what do we see right from the get-go? We see that we have this thing to use. We have this given x almost. So we want to put one of these into that form. Of course, we can't put the 3a in that form because we're doing the log of 3. So we're going to try to put this 2 to the 102 in that form. If you have been paying attention in an Algebra 2 class, you know we can do this really, really easily. Okay, let's do this. So log, oh, it was a bad log, bad log. Oh, shoot. There. Log 2 to the 102. What is that equal to? And there's a formula we can do here. The formula is right here. Let me show you. Right down here. Here's the formula. It's right over here to the side. It's a big formula, so in red. It's x log a b c is equal to what? If you've been paying attention in class, it's c times log a b, because this exponent goes down there. So applying this to this problem, we know that 102 times log 2 is equal to this. This is a true statement from this equation. So what we work on was, we have this now in our equation. We have this right here, right here. So log 3, and we know this because it's up here, right? So let's work onwards. Green. Log 3 to 102 to the power 102 is equal to 102. Oh, it was about 102 times 0.631 dot dot dot. Now this is really big, because now we have this 102, which we can isolate. So let's do that. I isolate this thing. Oh, okay. Let's move everything. Let's isolate it. So we can take 3, we can take the power to everything, right? 3 to the power of this. So now we have 2 to the 102, which is equal to 3 to the 102 times 0.631 dot dot dot. Now this problem becomes really, really easy, because now we have everything we need to solve the problem. Let's look at what we're looking for again, the smallest positive integer a, such that 3 to the power of a is greater than 2 to the power of 102. And look at this, we have this 2 to the power of 102, we have it right here, and we have 3 and we have a. This is a. But we realize that we have this integer thing, that this will not turn out to be an integer, which I don't think. This will not be an integer. So with a little bit of calculation, let's do it. A little bit of calculation, which we'll do down here. 102 times, sorry about that, times 0.631, and we have 64.362. So let's look back at the problem. 64.362, based on the information we have, should be the smallest positive number that satisfies this equation, right? But it's not equal to. It's not equal to. So we have to round up. In either way, we have to round up, because we need an integer and we need it to be greater than, not equal to, greater than. So we round up to 65, and sure enough, that is our answer.